Now that we've done some review from 20-1, we can start looking at some 30-1 problems. The rest of the section actually is a repeat of 20-1, so we're going to focus more on these word problems. An engineer designs a roller coaster that involves a vertical drop section just below the top of the ride. This is told. Let's say top. All right, now that we've taken. All right, now that we did a review of 20-1, we can start looking at some 30-1 word problems. Now, the rest of the section actually is the same as 20-1. That's kind of the nice thing. So we're already on that part. But now these word problems add a little bit extra layer of complexity. So an engineer designs a roller coaster that involves a vertical drop section just below the top of the ride. He uses the equation to model the velocity v in feet per second at the top of the drop and constant acceleration a in feet per second squared. The design specifies that the speed of the ride's cars be 120 feet per second at the bottom of the vertical drop section. If the initial velocity of the coaster at the top of the drop is 10 feet per second, and the only acceleration is due to gravity, 32 feet per second squared, what vertical drop distance should be used to the nearest foot? So first off, we're looking for vertical drop distance. That's our d value. So from the rest of the information, we should be able to find our other values. Our final velocity that we're looking for, we're told is 120 feet. So it's going to equal 120. We're also told that this starts at 10 feet. So our initial velocity is going to be 10 feet per second squared plus, and our acceleration we're given as 32. So that's going to be 2 times 32. And then we still have that d value that we're looking for. All right, so let's simplify the right side as much as we can before we do too much. And this is all under the root. So we get 10 squared is 100. 2 times 32 is 64. D. We're going to square both sides. So I get 14,400 is equal to 100 plus 64d. I'm going to subtract 100 off both sides. So I get 14,300 is equal to 64d. And then divide both sides by 64. Now in the calculator, you're going to get 223.4. But this says to the nearest foot. So it's going to be 223 feet is equal to d. All right, let's look at one more word problem. So a disposable cup has the shape of a cone. The volume of the cone is v, the radius is r, and the height is h. And the slant height is 5 centimeters. So we have cone volume is equal to 1/3 pi r squared h. Derive an equation that expresses the volume of the paper cup as a function of r, v of r. This means make the volume equation only have one variable in the equation, r, instead of height and radius. So if we just sketch out a cone, there we go. Now we're told the slant height is 5 centimeters. Now we want to make this only have r in it, so our radius of our cone. So there's our r right there. What's missing, or what the connection between slant height and height is our height of our cone. So that would have been a grade 10 concept. And if you look, we can actually see a right triangle there. So that means I can use Pythagorean theorem. This is going to be h. So then I have h squared plus r squared equals 5 squared. Make sure you square that. That's where we're going to get you. Now we want to make this so that this h is gone. We want to be able to substitute something into that h variable. So I'm actually going to solve for h here. So h squared, I'm going to subtract r squared from both sides. I get minus r squared plus, well, 5 squared is 25. Then I'm going to square root both sides. So I get h is equal to plus or minus the square root of negative r squared plus 25. Now I know that I can't have a height that's negative, so therefore I shouldn't have this minus here. That you need to explicitly say that though. You can't just not put it. We're going to assume that you don't know what you're doing then. Okay, so I've got my h. Next, I need to substitute that h value back into this original equation. So I've got my volume is equal to 1/3 pi r squared. And then h is going to be substituted for the square root of negative r squared plus 25. And there we go. It's written in Oh, it's very close. It says V of R, so this should be function notation. Make sure you're reading that as well. So volume of V of R. There we go.